Welcome to the deep dive. We're kicking things off today by immersing ourselves in the cool science of thermal management.
Yeah, specifically looking at a new material that's, well, generating some buzz.
Right, the JunPus JP-DXSquare Elite. It's a new flagship thermal interface material just launched this year, 2025.
And its whole purpose really is handling the crazy amount of heat you get from today's most demanding tech.
We're talking things like AI processors, those complex EV battery systems.
High-performance GPUs, definitely, and, the servers that run pretty much everything these days.
And it had quite a prominent debut, didn't it, at CES 2025?
It did, yeah, which is interesting, I think. For a specialized material like this, showing up at CES suggests they're pretty confident it can make a real difference across a lot of advanced tech.
Absolutely. So our mission for this deep dive is, well, pretty straightforward. We want to figure out what makes this JPDX Square Elite noteworthy for you if you're someone keeping tabs on cutting-edge tech and, efficient solutions.
We've got some interesting bits from a previous chat about it, and we'll pull out the key stuff, really dig into what makes it tick.
Okay, let's get right into it then. The core technology, what's under the hood?
So the performance of this JPDX Square Elite really hinges on its unique composition. It uses square nanodiamond particles.
Square. Okay, that sounds different. Not just a gimmick.
Apparently not. The sources suggest this square shape actually provides a larger surface area for contact. And crucially, they can pack together much more tightly than, say, traditional round particles.
Right, I saw that. Something like 25% better gap filling compared to the spherical ones? That sounds significant.
It really is. And filling those tiny microscopic gaps better is absolutely key because it directly lowers thermal resistance.
Okay, break that down a bit. Thermal resistance.
Think of it like friction for heat is how hard it is for heat to move away from the source. So by making better contact and squeezing out those little air gaps, which act like insulators, the heat transfers away much more easily.
Which is vital in high-performance computing, right? Where even a small temperature bump can throttle performance.
Yeah, exactly. Every degree counts there.
And the numbers look pretty good. We're seeing a thermal conductivity of 18 watts per meter Kelvin.
Which is solid. But the thermal resistance figure is, I think, the real eye-catcher.
Yeah, 0.008 degrees Celsius centimeters squared per watt. That seems incredibly low. Though that's under specific test conditions, right? 50 psi, 25 degrees C.
Correct, JunPus's white paper data.
Yeah.
But it points to very minimal resistance to heat flow.
And we had that comment from Maria Chen, didn't we? Ex-Foxconn thermal buyer.
Yeah, that was interesting. She mentioned hitting under 0.01 UCM in Yorbu with a really thin layer, just 50 micrometers.
And she said that was something she hadn't really seen with typical non-conductive pastes.
Right. So that kind of real-world perspective really underlines the potential impact here.
Okay, so the foundation is these unique square nanodiamonds giving better contact, lower resistance, good conductivity. Let's talk performance. Where does this actually make a difference?
Well, one thing that stood out was its consistent performance across different thicknesses.
Right, from 50 micrometers up to 400, tested by Igor's lab.
Exactly. That stability is valuable because, different applications need different TIM thicknesses. You don't always want it super thin.
But it sounds like it really shines in those very thin applications below 100 micrometers.
It does seem to have an advantage there, yeah, especially in high compression scenarios.
Like cooling GPU dies directly, or those high-pressure contact coolers.
Precisely, which, given that super low thermal resistance we talked about, makes a lot of sense.
So thinking about applications, this seems tailor-made for those beastly new chips. NVIDIA H100, AMD MI300, the AI and HPC stuff.
Absolutely. Getting heat away from those cores efficiently is critical for keeping them running at peak performance and, making them last.
Makes sense. And what about EVs? You mentioned battery systems earlier. How does it fit there?
Well, in those big, dense EV battery packs, keeping temperature stable is crucial. Not just for performance and range, but for safety too, preventing thermal runaway.
Right, that's always a concern.
So a material like this, if it efficiently pulls heat away from the cells, helps keep the whole pack at a more even optimal temperature. That contributes to reliability, battery life, the whole package.
Okay, so big industrial uses, but it's not just for them, is it? What about like PC enthusiasts, overclockers, people with heavy-duty workstations?
Oh, for sure. For overclockers trying to squeeze every last megahertz out, or pros running simulations on workstations, stability under load is everything.
Preventing that thermal throttling.
Exactly. Better heat dissipation means you can push the hardware harder without it automatically slowing down to protect itself. Keeps things running smoothly.
And then there are servers. The backbone of everything digital, especially with AI driving up power density in racks.
Yeah, data center cooling is a huge challenge and a huge cost. Better thermal management at the component level, using something like the Elite, can improve heat transfer away from CPUs and other hotspots.
Which could mean less need for, like, blasting the AC.
Potentially, yes. It could allow for lower fan speeds, maybe less aggressive cooling overall. And when you scale that up across a whole data center, especially with AI racks drawing more and more power, the energy savings could be pretty significant.
Okay, broad applications. What about the practical side of things? Using this stuff, safety, that sort of thing.
Good question. The sources do mention some practical points, like the formula is described as non-toxic and low volatility.
That's good to hear. Environmental concerns, user safety, always important.
Definitely. And it seems built to be quite robust physically.
Stable properties, you mean?
Yeah. Works over a wide temperature range, like -40°C up to 180°C. It's a gray paste, densities 2.58 GC-meter/ever.
And the viscosity. I saw a number, 3,900,000 myobs. That sounds thick.
It is thick, like very thick honey, maybe. That helps it stay put, which is good. But yeah, we'll touch on how that affects applying it in a minute.
Okay. And it seems they're set up for different scales of users.
Looks like it. They've got ready-to-ship options from little 3-gram syringes, maybe for you building a PC at home, all the way up to massive 10-kilogram pails for industrial manufacturing lines.
Caters to everyone. What about regulations? Certifications?
Cover there too, it seems. ISO 9001 for quality, RoHS for hazardous substances, are each for chemical safety. Standard stuff, but important boxes to tick.
And the documentation comes in multiple languages.
4 languages, apparently,
Yeah.
which helps for global companies dealing with different regional rules.
Now, this caught my eye. Bulk price locks with hedging against silicone costs. What's that about?
Yeah, that's interesting for high-volume buyers.
Yeah.
Basically, they're offering to lock in a price for bulk orders for 6 months, protecting buyers from potential spikes in the cost of silicone feedstock, which is a key ingredient.
So predictability for big customers. That makes sense.
In a volatile materials market, that could be a really valuable perk.
And they offer direct support for integration, too. Design in teams.
Seems so. Labs in Taipei, Munich, Dallas, promising a 48-hour response. That kind of hand-holding can be crucial when you're designing a new product around a material like this.
It's not just the material, it's the support package.
Exactly. And they even have a marketing toolkit for partners. Renders, CFD graphs, A/B testing scripts.
So if you're a reseller or integrating it, they help you sell it too.
Looks that way. Helps their partners get it to market faster.
Okay, technology, applications, practical stuff. Check. But what about proof? Any real-world examples showing this or similar JunPus stuff actually working?
Yes, a few compelling little case stories came up. One was a European esports brand, Invictus.
Okay.
They switched to a different JunPus TIM, the DX1, not the Elite, but still relevant, and they saw a 28% drop in GPU RMAs.
Wow, 28% fewer graphics cards coming back faulty. That's huge.
It really is. Shows how much difference effective cooling makes to reliability and ultimately cost.
Any others?
Yeah, a North American hyperscale cloud provider.
Yeah.
Big data center operator. They tested the Elite specifically on their GB200 server pods.
Yeah.
They measured a 3.8 degrees Celsius temperature reduction. Doesn't sound like much, maybe.
But in a server rack.
Exactly. It let them cut their cooling fan speeds by 10%. The estimated saving, US $18,000 per rack per year.
$18,000 per rack. That is serious money at scale.
Massive operational savings potential there.
It's not just about the peak performance then, it's long-term cost and reliability.
Precisely. And on that reliability note, there was a Japanese EV Tier 1 supplier.
Automotive sector.
Yep. They signed a 3-year LTA, a long-term agreement with JunPus. Why? Because the Elite passed 1,000 thermal cycles in testing with 0 oil bleed.
Oil bleed. That's when the paste separates over time, right?
So-
Affects performance.
Exactly. So passing that kind of tough, long-term automotive test, especially with 0 bleed, really speaks to its stability and suitability for demanding environments like EVs.
Okay, those examples definitely add weight. Now, let's play devil's advocate a bit. Potential concerns. The sources mention a risk-reward table.
Right.
One, obvious one, price. It's apparently about 25% pricier than standard thermal pastes. How do they justify that?
Yeah. Price is always a factor. The counter-argument seems to be the 3 to 4 degree temperature drop we keep mentioning.
Okay.
For manufacturers making loads of devices, even a small drop in temperature can mean fewer units failing right out of the box dead on arrival, or DOA. The estimate mentioned was a 0.3% reduction in DOA boards.
0.3% sounds tiny.
It does, But if you're making millions of things, 0.3% fewer failures saves a lot of money on warranty, replacements, reputation, potentially more than the extra cost of the paste.
And they have ways to soften the blow. Bark deals.
Yeah, bundling options for the big pails and rebates once you buy a certain amount, like 100 kilograms, trying to ease that initial sticker shock for volume buyers.
Okay, what else? That high viscosity we talked about, making it hard to apply with automated jetting systems.
That's a valid concern for manufacturing lines. But the material, both DX2 and the Elite, has this property called shear thinning,
Shear thinning meaning.
meaning when you apply pressure, like 30 psi or more from a dispenser, it gets much less viscous. It flows easily. Think of ketchup thick in the bottle, flows when you squeeze it.
Ah, okay. So it is compatible with jetting, despite the initial thickness.
Seems so. And they're also offering a loaner program for the right kind of pneumatic dispensers, so companies can try it out in their own setup.
Removing another barrier. Okay, last one. JunPus maybe isn't a household name outside Asia. Brand perception.
True, they might not have the immediate recognition of some older brands in, say, Europe or North America, but the numbers show they're not small players. 12 million syringes shipped last year alone.
That's a lot of paste.
It is. Plus, they snagged a Computex Best Choice Award this year, 2025. That helps build credibility.
And they're helping partners build the brand too.
Yeah, offering a co-marketing fund. Like 5% of the first year sales volume for new partners goes back into helping them market the JunPus products, sharing the effort, basically.
Sounds like they've thought through these potential objections. So for our listeners who might be distributors or OEMs or even high-end PC builders,
Yeah.
what's the next step if they're interested?
Well, JunPus is actively looking for partners right now. They mentioned opening 30 global slots for fast-track partners before Q4 this year.
Who are they looking for specifically?
Distributors, OEM integrators, companies that would build this into their own products, and even those boutique PC builders focusing on top-tier performance.
And how do you get in touch or learn more?
There's a link in the description for this deep dive, or you can email them directly, sales@junpus.com. And here's a tip. Mention the comment Edge of Cool.
Edge is cool. What does that get you?
A free 50-gram engineering sample kit, and they say they'll get it to you in under a week. So a really good way to get hands-on and test it yourself.
Nice offer. Okay, just a couple of quick-fire details from the Q&A section we saw. Minimum orders.
MOQ is 500 pieces for retail packs, 12 kilograms for the industrial bulk stuff,
Shelf life.
over 36 months, as long as it stays nitrogen-sealed in its packaging.
And sampling, besides that 50-gram kit.
They do a standard 5-gram syringe sample, which comes with the MSDS, the safety data sheet, and the spec sheet, all the basic info you need.
Got it. And finally, if someone just wants to buy it or find out more technical detail.
Right now, the JP-DXSquare Elite is available directly from the JunPus official website. They also mention offering OEM and ODM customization services if you have really specific needs.
So the website's the main portal.
Yeah. For more tech support, detailed specs, or just to browse, visiting the JunPus official website is the way to go.
All right, so wrapping up our deep dive on the JunPus JP-DXSquare Elite. The bottom line seems to be it's a genuinely high-performance thermal solution, really built for those tough, high-heat applications we started with.
Yeah, the potential value proposition looks strong. It's built on that core tech giving better thermal performance, the reliability shown in those case studies, and features that seem pretty well tailored to specific industry needs from gaming rigs right up to EVs and AI data centers.
It really makes you think, doesn't it? How advances in material science, like this whole square nano-diamond approach, are constantly pushing the limits of thermal management.
Absolutely. And that progress is what allows engineers to develop even more powerful, more efficient technologies across the board.
Things like AI, electric vehicles, they rely on being able to handle the heat effectively. It's a critical enabling technology, really.
It really is. So maybe something for you to consider is how these behind-the-scenes improvements in materials continue to unlock the next generation of tech we interact with every day. Food for thought.
Definitely. Thanks for exploring the deep with us.